record and share my screen. Some of you who've gotten stuck with weird issues, like weird Django environment issues, I think that's it's unfortunate. It's also a pretty common part of development. But you shouldn't let yourself get stuck too much on that. If you're able to get anything running, you should be able to start deploying to Heroku. Like if you got stuck on the table does not exist problem, you should still be able to deploy to Heroku. And I have a sneaking suspicion that it might work on Heroku, even if it doesn't work on your local machines. So that's an interesting experiment that we'll hopefully see. No, I mean that if you've hit MVP, that you can actually start working on this one early. There's a few reasons for that, and I mean specifically for this one, the challenge is to deploy to Heroku, and taking 3 hours, it can sometimes take longer than 3 hours, and it's not your fault. Like it's because there's something weird with the environment, with your environment, or Heroku servers are being finicky, or there's a million reasons why it could go longer than 3 hours. And for all practical means and purposes, it's not. This isn't something that you would ever need to do quickly. Things like code challenges, like if you're solving an algorithms problem, it is useful to be able to do this under time pressure, because you're going to come across coding challenges like in your interviews, where you're going to have 40 minutes to complete an algorithm, and it's important to be able to do these in a set amount of time. Heroku deployment is not one of those things. Like, it's very important that you know how to do it and that you understand the concepts behind it. But I talked with the CS team, and we all agreed that it's that testing under time pressure does not really get us any more benefits. And we would rather that everyone gets it complete and gets their Heroku deployed, rather than having you stress out over trying to get it done under time pressure. When you're stuck with some mysterious bug and you have 30 minutes left and you're just freaking out. It's also very important. We want to make sure everyone gets their code deployed, because your next project needs to be deployed. You're going to be running a Django server for an API, and then building a front end for that. So if you're not able to deploy your Django project to Heroku, then you're not going to be able to do the project. And we don't want you to be stuck on that. We want you to hit the ground running with this project. So my plan for today is to I'm going to talk about Heroku a little bit for the first half. Talk about what Heroku is. There's a lot of stuff if you look at the sprint challenge. I'll drop this into Slack. There's a lot of stuff here, and there's a lot of moving parts to deployments, and I'm going to talk through them. But before I get into that, I want to make sure that that we cover everything from this week. So we covered, what do we see? We looked at the intro to Django. We looked at the interface. We talked about SQL with SQLite. We implemented a RESTful API, and then we implemented token auth. So that's a lot of stuff, and we went through it pretty quickly. So before I move on, I want to answer any questions that anyone has from the previous week. Especially I want to think about the iOS students, because I know a lot of these concepts, the web students have gone over them before, but for iOS, some of this may be the first time you're seeing some of these things. So anyone, iOS, web, let me drop some questions into Slack if there's anything you want to go over for that we've gone over for the previous week or for this past week. Got it deployed to Heroku. Migrations worked. Was able to add super user through Heroku console, but had the error module not found. No module DJ org 2 when it ran your proc file. Is DJ org 2 the name of your project? It's not DJ org. Okay. That's getting ahead a little bit, Marshall. We can look at some debugging offline, maybe in the help channel, maybe with your PMs, or I can also jump in and help. Oh no, don't apologize. Don't apologize. But let's get through this stuff in order. So first, anything from this entire week. Okay, I accept your apology for apologizing. Is it possible to use Django API Kit to support put and delete methods? Yes, absolutely. Absolutely. Let's what is it? API? Is it an API? Is it in views? What project am I in? URLs. Okay, so there's this path, there's posts, so we go to admin site URLs. These are all built in, so we can't really look at them, unfortunately. I can open maybe cd LambdaMUD. Oh, that's the new one. LambdaMUD. Let me see if I can find some. I think this is an API. Okay. Here's this is some API stuff from the LambdaMUD project. And you can see here I made a get, I made a post. You can also build your own delete functions. But to answer your question, yes, you can definitely use do put and delete functions. I think you can probably look that up on your own to see how to do those, but that would be a good stretch as well to see if you can create API commands to delete notes. If you do that, you want to make sure that you have your permissions correct. So you want to make sure that if you're deleting a personal note, that only the person who owns that note can delete that personal note. You also usually admins can do anything. So setting up permissions is an exercise that you can do yourself if you're curious. Is Django best used for situations where you need to easily access the backend's database? How does it compare with something like Firebase for persistence? As far as persistence goes, I think they're equal. Firebase, I haven't used Firebase before, but let me see. How do I answer this question? So Andrew, you're iOS, right? So I think on iOS uses SQLite to store databases locally. So when you talk about persistence, I think you're a better comparison would be between databases. So Django is not a core data uses SQLites. So Django is not a database. Django is a web framework that lets you interact with a database. It's sort of a layer between it. The database would be Yeah, so the database is SQLite or Postgres or MySQL. Those are actual databases. And when you look at when we get into the sprint challenge, you're going to see that SQLite does not really work very well on Heroku. So you're going to be setting up a PostgreSQL database. That is POST GresSQL. Like that? I don't know. There's some weird capitalizations here. But Postgres is a fully functional database. SQLite, as is implied by the name, is sort of a lighter database that it works, and it's nice because it stores everything in this little local file, but it's not as powerful, and I think it's not as performant as something like Postgres. But it is lighter weight, which is good for things like mobile devices. PAAS versus BAAS. What are PAAS and BAAS? So I think when you're talking about persistence, things like that, then it's more about the database. Now databases work with different frameworks, so you can use with Django, when you're developing locally, you can use SQLite. You can also use Postgres. You can probably use MySQL. I haven't used MySQL before. But these are the databases, and those have a lot of different characteristics. Django is a framework that you build around it. That's why they're called web frameworks. So Django is a way of interfacing with that database. What's a good analogy? I guess I don't have a great analogy for this, but maybe okay. This is very imperfect, and maybe it's confusing. No, okay, yeah, I think my example is confusing. But I think Django is good if you like Python. That's one short answer. Django is really good if you like Python. Django is really good if you want to set up an API server very quickly, and you don't want to have to go through a lot of the headaches of setting things up yourself. As you've seen, a lot of it happens by magic. Django is also nice in that you can dive into all of the source code, which you can see. Let me see if I can bring up an example here. So, which Python? Okay, so when I type which Python, you see I have my virtual environment here, and I can look here and see lib, sites, packages. Okay, so I can see all of, why is my thing messing up? This is weird. Okay, well anyway, you can see all of the code that's actually running in your, like decouple. Remember when we did install decouple? Well, that's just creating this this Python code here. So you can actually go into there. So like, is this better? It's not better. All right, I'm gonna open up a new tab. Lib, site, packages. Lib, sites, site, packages, decouple.py. Okay, so you can actually look at all of the Python code here and see what's running. And if you want, you can do whatever, anything you can do in Python. Like if you want to see what the repository is, you can print repository. You can really get into the guts of what it's doing. So even though there's a lot of magic and things happen by magic, there's also this level where you can dive in and see what's going on in the guts. Now again, if you like Python, which I do, I actually really love Python. It's my favorite programming language out of the dozen or so that I know. And if you like this structure, then Python is really good. Ruby on Rails is very similar to Django, except it's in Ruby, and Ruby has a very different philosophy. Like anything you can do in Ruby, you can do in Python, pretty much. Anything you can do in Rails, you can do in Django, but there's different philosophies around it. The web students do Node and Express for their backend, and that's also very good for creating a lightweight API server. That's written in JavaScript, which is nice because then your front end code is the same as your back end code. So it creates sort of a uniform environment where it's easier to move back and forth. But there's pros and cons behind everything. Platform as a service versus backend as a service. Full stack would have to learn front end and back end as an implicit process. iOS engineering is about interface design. Before that, you had Parse, which Facebook shut down. So I wonder, like I'm not really an iOS developer. Like I have an iOS app on the App Store, which I built in Unity. So it's not really, I didn't write any Swift code, but I have some experience with that. But my app has a database as well. It's running on a Ruby on Rails database, which is sort of basically what we did here. I created an API server. I'm using a Postgres database. It's hosted on Heroku. And it handles all of the it handles accounts, logins, storing stats for different user accounts and things like that. So I wonder how many iOS developers consider themselves full stack iOS developers, and that they can create APIs for their own iOS apps. Basically, you're a one-stop shop. You can do it. You can do everything that's needed to create a fully powered app. After this, you should be comfortable to start doing that. Like if you want to create an iOS app that manages your own users, now you have the tools to do so. And you'll also be creating a full product for next week that with using user accounts, using Django authentication and all of that. So you could consider yourselves full stack iOS developers. I don't know if that's the thing. Yep, I use Rails for that app. What else? Yeah, I've also built the backends and worked with iOS developers. I'll talk about more of that when we get to the second half of this lecture, because that's gonna be touching on what we're doing for Project Week. But I think this stuff is really good too. I think this stuff is really good for you all to know about. One of the goals of computer science is to demystify computers and computing. And, when you're an iOS developer, I think even if you're primarily developing interfaces, I think we still want you to know what's going on, like what's going on behind the scenes of your API server, right? You don't want it. It's not just a black box that you send a request and you get something back. Like we want you to have a sense of what's going on underneath. If you have a sense of what's going on underneath, you can get a sense of, all right, what's okay to stretch? Like how can I push it, right? And what happens if something's going wrong? What happens if my performance is starting to degrade with the API server? Maybe it's something you're doing, maybe it's something you're not doing, but if you at least have a sense of what's going on underneath, you can start to think, hey, we need to fix this. What can I do on my end? And maybe you can gives some insight on how that all relates. In general, the whole point of computer science is really just to broaden your understanding of everything that's going on with programming and code and computers and networks and scale and all of these things that you can probably get by without knowing, but knowing these things will make you a much better developer. React Native is a really cool project, is a really cool technology, and it'll allow those who are in the web space to dip their toes into the mobile space without having to go through Lambda School iOS track. So that I agree. I also want to learn React Native because I think it's a really cool tech. Let's see. I have a couple of apps. My main app. I don't even want to share it because I'm working on a big update, and I don't want people to look at the old one because the new one that's coming is so much better. So maybe I'll announce it when it comes out. But I mean, you can find it. It's a puzzle game called Godai, Godai. It's on iOS and Android, the Google Play, and the iOS App Store. So if you like puzzle games like Tetris or Super Puzzle Fighter, things like that, then give it a shot. I'm also anyway, that's getting way off topic. But if you want to look, it's Godai, Godai. But don't judge it yet. Don't judge it yet. I have a huge update coming out in maybe a month or so. When I can find the time between working at Lambda School to finally get that update out. I'm like 95% there, but that last 5%, as some of you may know, that last 5% is always the hardest. All right. Let's see. Any other questions? What else can we talk about from here? Virtual environments. Deliverables, RESTful API. Oh, this is already added as a stretch. So you can do put and delete. Are we feeling pretty good? Are we feeling pretty good about this week's material? Seems like let's see, 75%. All right, that's pretty good. And then the rest are really close. So it seems like people are feeling pretty good about this stuff. All right, let's start taking a look at Heroku. What is Heroku? Let me see. Let's do a poll. Thanks, David. Have you used Heroku before? Let's just make it yes, no, and have you used Heroku before? No. For those of you who put no, have you deployed to a different service, and if so, which one? There's hosting like Google Cloud, there's AWS, there's DigitalOcean, I think it's called. Excuse me. Or so for those of you who are no's, if you've done something else, drop it in here. Or if you've never deployed any code to any hosting server, which I imagine the iOS students haven't, and that's fine as well. Okay, cool. Well, it seems like we're about half and half, which is good. Good motivation to start talking about to start from the very beginning. What is Heroku? What does it mean to deploy code to a hosting server? These are great questions. So let's start way back at the beginning. What is the internet? All right, let's start with the 1,000-mile view. What is the internet? Okay, the internet. You have your computer. and you have servers, right? You have this huge network of servers. Between those servers, there's routing hubs all over the country, and these will when you send a message, you send a request from your computer. These network hubs will route them using graph search. They will route them to the appropriate server. So when you may have heard the term IP address. So every computer, every server, everything on the network has a unique IP address, and they're routed through these network hubs. So like let's say if I want to visit google.com, I'll type in google.com. That will be converted into an IP address. Like Google is you have like a DNS host which will convert. Like google.com is a human readable address, but then it converts it into some number and then like a IP address, and it'll route it to a server. What is a server? Well, a server, when we're talking about Google, is they have these humongous warehouses full of just racks and racks and racks and racks of computers. These, when we think of computers, we usually think of personal computers, like a laptop is a PC. And that has that has things like a keyboard, it has things like a monitor, speakers, a mouse. It has these interfaces. But when we're talking about servers, they're computers without any of that. They're literally just machines that compute. The input and the output all comes from, is all handled automatically. So when you have these racks of servers, these take a bunch of incoming requests and they send responses. So when you type in google.com, you'll send out a request. It will get routed to the Google servers, and then that Google server will return like what this HTML or whatever is. Now, when you have a big site like Google, they're actually, it's not just one place. It's it's what's called distributed servers. So they have, if you look up, let's see, where are Google servers? All right, so Google has 12 significant data centers located across the United States. So if we look at this map, can we get it bigger? All right, you can see where these data centers are. So they're actually physical locations, and when you go through the router, they have things called load balancers, which will direct you to the closest one. And since we're talking about sending things across the country, there is actually a non-trivial amount of time that it takes for the electricity to travel from your computer through all these thousands of miles of wires in some cases and hits the server. And then it processes in some milliseconds, probably pretty quickly since it's Google, but it'll take time to process, and it'll send it back through all of these wires. And each time it hits a hub, it needs to do some processing there as well. And these things all happen really quickly, but this is what happens when you type in just a web address. It needs to run through a ton of like dozens of network hubs, hits a server, the server takes it, processes the response, and sends it back. So when you develop locally, you can see what you have a server running on your computer, right? Like you run server, and then the server waits. It waits till it gets an input, and then it sends an output. And when you run locally, it abstracts all of that travel time, so it happens instantaneously. But it's basically the same thing. You can set up a server on your computer that accepts traffic from outside of your computer, which if you've ever done something like hosted a Minecraft server, your computer, your physical PC is that server. And then people are making requests, it gets routed to your computer, and then it sends the responses to your friends playing Minecraft across the county. You'll notice if you ever tried to do these things across like from the East Coast to West Coast, it takes longer, and that's just because all of these signals need to go through much longer distance. Now, that's not very practical. If you're doing if you have a if you want to host your own code, like if you want to host a website, it's not very practical to host it yourself. For one, you would need to keep your computer on 24/7, which it takes a lot of electricity. Another is all traffic is going to be routed through your personal internet. So that means it's going to go, I don't know how much bandwidth you have, but it's probably capped at a certain amount, right? So all of that traffic, anytime someone visits your webpage, it would have to go through your Comcast or whatever. It would have to go through your wireless router. It would have to be sent to your computer, and it would have to be sent back. So that's not very practical. So what standard also it's not distributed. So you're like, if your house is here and someone across the country wants to visit it, it's going to take that much longer to hit your stuff. So that's very impractical. Yeah, you could. I mean, people definitely do this stuff. Some people like to have private servers. So if you want to be on the dark web or whatever, and you don't want your code to your website to be accessible in the greater web, the greater internet. You don't want your stuff to be searchable on Google. You can host a private server, and people definitely do that. But if I don't think that's what you guys are coming here to do, right? Like you want people to find your stuff. You want your stuff to show up in Google. You want there to be fast access. So that's why that's why we use hosting services like Heroku. So what does that mean? Let's see where Heroku servers are. So Heroku is a subset of Salesforce. So let's see, where are Heroku servers located? Regions. Is this the list? I don't think this is the list. Is there images? How do Tor web browser and .onion URL work to protect privacy? I don't know the answer to that, Ty. I'm not. My hacker skills are very, very elementary. Let's see. Maybe what if we say data centers? Salesforce data centers. Main production data center. Okay, I think that's what this map is saying. Okay, so Salesforce has a data center here on the West Coast. I think it's in Virginia. One on the West Coast, or two on the West Coast. One looks like this is in Washington area. One's in California, and one way out here. So when you deploy your code to Heroku, so Salesforce, let's talk about Salesforce first. Salesforce is a SaaS company, so software as a service, B2B, business to business. So Heroku creates software that businesses use, and they're a humongous company. In San Francisco, Salesforce has the tallest building, which is, it's not all about size, but for what it's worth, Salesforce has the tallest building in San Francisco. And they're humongous, and they have giant server farms, huge data centers, and they have tons of bandwidth. So what is bandwidth? When you think of network speed, there's sort of two key metrics that you look at. One is bandwidth, and one is, I'm going to forget. So there's basically speed. Um, so how fast can data go through, and how much data can go through at one time. If you think of it like a bridge, and networks are based, you can have a wider bridge. That means you can get more cars through at one time, or you can have like a faster speed limit, which means that one car can get through very quickly. But if you're running out of bandwidth, that means too many people are making requests. Then it doesn't matter how fast your speed limit is, right? Like, what if you have a 2-lane bridge during rush hour traffic? Then everyone is just going to get clogged up. So that's what happens when you don't have enough bandwidth. At the same time, you can have a 10-lane bridge, but if your cars the speed limit is 40 miles per hour, then it's still going to take a while to get across. Data centers have humongous bandwidth, and like that literally means like they have giant like fiber cables, like very, very large amounts, which allows many, many simultaneous requests to go through. They also have racks and racks and racks of computers that of servers that can process things very quickly, and they also have a lot of storage space. These are also distributed, and there's a lot of redundancy. By that, it means like when you deploy your code, when you put your code on one computer, it's not actually just on one computer. It's on many different computers. So whichever one is, so if one fails, then you can just go to this one. And there's a ton of software about routing between these things. That's a really interesting topic. And if you're like load balancing is pretty cool. But basically it will, these servers, they'll let you rent out space on them, and then it lets you use their super fast access, their distributed data networks, and all of that. So it's much, much more practical to deploy to these different hosting services. AWS is owned by Amazon, and Amazon owns a lot of servers too. Google, you can use Google Cloud to host these things. Google has a lot of servers as well. Basically, you're renting some space on these giant data centers, which let you duplicate your it lets you use their performance to host your site. Any questions about that? Any questions about what a hosting site is and why you might want to host? There's also so when you have a URL like GoDaddy, like you go to GoDaddy, you buy a domain name like Brady. I own bradyfukumoto.com. So my website is hosted on Heroku, but all that is reserving the name, and then my name points to the address in the Heroku server. So underneath, I think like brady@herokuapp.com is pointing to my website as well. To clarify, Heroku just stores the data. So it's not data, it's your server, it's your server code. So when you say data, Andrew, I think of database, right? So it's not hosting your database. It is hosting your database, but it's not just hosting your database. It's actually hosting your server code. So what I mean by that is, let's take a look. So here, this is our code, right? SQLite, this is the database, db.sqlite3. It's all of the, like my users, my usernames, my notes, all of the content in the notes. That's all contained here in the database, right? So that's my data. Heroku does host that. Heroku does host your database, and they have huge banks of disks, of like just hard disks of, I mean, it's probably not so many disks anymore because they're very prone to mechanical errors, but they will host your data, but they also host your code, your server code. So that's things like your API server, right? Like your routing. Like what do you do when you get a request, an API request? You will, you want to route it to this personal note view set. When we go to our personal note view sets, where is that? Here. Then you run the serializer, you get your query set, you get your notes. All of this is actual code. So that code is hosted as well. So they're hosting your data and the functionality. And their computers are going to be really quick. When you're running your server on your PC, on your personal computer, it's not it's still pretty quick. It's still really fast, right? Like it happens in a fraction of a second. But your computer, it's optimized for different things. So like on my MacBook, I'm running video, I'm running Zoom, I have this really nice desktop with fancy icons that have nice like shiny effects on them. It's tracking my mouse. I have audio. It lets me connect to like consumer internet. I have updates running in the background. I have antivirus. I have all of these things going. Servers on Heroku. That is Heroku servers only run code, so all of their cycles are dedicated to running that code, and they're really fast. So their performance is going to be much higher. What does the R on line 29 mean? I think this means raw. Raw or regex? Is it for regex? I think this is for regex. This means that you can. Is it? I forget. Yeah, I think it's for regex. But is it for regex, or is the RE path for regex? Let me Python R string. Yeah, I thought R was for raw, but this guy is saying there's not really any raw string. It's a byte string. Okay. So I think, sorry to depart, but it's a good question. So you want to do raw for regex. So the RE is for regular expression. For regular expressions, you want to use raw strings. And what that means is, you can have escape characters like \n will give you a new line. Raw strings just treat every character as their own literal character. So it will not include escapes. And that's important for regex because regex will process escapes differently. So you need R, I think technically R is for raw string, and then this RE path uses the raw string to and treats it as a regular expression. All right, so let's see. That's what Heroku is. That's why we want to host our stuff on Heroku. Heroku also has all different versions of everything installed. So if we're using Django 2.1.1, Django, they have that on their machines. If you're using Django 2.1.2, they'll have that on their machines. They have all different versions of everything. If you want to host Ruby on Rails, my Ruby on Rails code is also hosted on Heroku, so you can do that as well. Basically, these are great. These are great ways to host your code to get better performance, and also to increase. Also, so you don't have to waste your bandwidth, right? Like if everyone's visiting your stuff, you don't have to keep your thing plugged in, get high power bills, and waste your internet bandwidth. Another thing that they can do, another thing that Heroku can do is it can add workers. So so we're doing this project, and as you work on your project next week, you'll start to see that if you have a lot of people playing, your server will start. Servers can only do one thing at once, and if you have 1 million requests all coming in 1 second, it'll have to serve them one at a time. So people will be waiting, right? Like that'll cause lag. That means that's what happens when you request a website, and you're waiting for it to come back. It could be that their server is overloaded. What Heroku does is it allows you to add workers. Which is you can pay for that. I think like for basic it's like $7 per worker, but you can have multiple workers serving those requests, and those are handled through load balancers. Where if you have 10 people if you have 10 workers working on it, they can all work in parallel to process these things all at once. It's like if you have a checkout line, right? If you have 10 people waiting in one line to check out, you just add another checkout person, and then it can get everyone through. It can handle everyone's requests twice as fast. And Heroku is nice because it's really easy to do that, and they prorate it, which means they round off to the nearest second. So if you just want to if you want to add some workers to try it out for like a few minutes, it'll only cost you a few pennies, and then you can turn it off and go back to regular workers. And it's pretty inexpensive. The company I worked at a company before that had like 1 million monthly active users, and their entire Heroku bill was pretty low. It was something like $50 or something, $50 per month, which, that's a lot for like an average person, but it's still less than my regular internet bill, So Heroku is a pretty great service. I haven't used AWS or Google Cloud, but I know that they're similar in that they offer all of these services. All right, so you're going to be deploying your code to Heroku for the sprint challenge. There's a lot of stuff. Read through it. A lot of it is boilerplate. One of our tasks for that Lambda has given the instructors is to standardize the templates for our sprint challenges. So you'll start to see all of your sprint challenges look like this, and a lot of the text is going to be similar. But still try to read through it. Comments, description, deploy, self-study, essay questions. Don't forget this. Don't forget to answer this part where you answer questions. Project setup. Now there's some tricky stuff that's going on here. One, sign up for Heroku. So Heroku is a free account. Make your account. I use my Heroku account a lot. Install the Heroku CLI. That stands for Command Line Interface. That'll let you do Heroku commands. And Heroku works nicely with Git. When you push your code to Git, you say git push origin master. That's pushing to the Git origin. If you want to deploy your code to Heroku, all you have to do is type git push Heroku master, and all of your code will be on Heroku. Easy as that. It's super easy. If you had a Django database with millions of users and you wanted to implement an algorithm for fast searching, where exactly would you implement the algorithm? Somewhere on the server API? It depends what you are doing with it. If you want it to be user facing, like if you want to have, like let's say you're creating a social network, right? And you have 1,000 users and you want to search for someone's name, or like a CRM, customer relation management software. I forget what CRM stands for, but like for one project I worked on was building the database for a travel agency, and they have thousands and thousands of customers, and they want to type in the name and get their customers back. So if you're doing something like that, then you want to have that code on the server. If you're doing something like a one-off, what you usually do is you pull, you get a database dump, so you get a copy of the blob onto your local machine, and then you can run operations. You can run operations on that, so you don't overload your server. But one day, it depends what you're trying to do. Would be my maybe unsatisfactory answer. All right, so from your terminal, you type Heroku login. It's pretty simple. If you're using virtual env, use pip install, migrate to pip env. All right, so here we're starting to get into some weird stuff. What is Gunicorn? Unicorn? I don't know how to say that. Gunicorn? Okay, so Gunicorn is a type of server. What does that mean? Well, when we talked about you have a server that's hosting your server code. Well, actually, there's different kinds of servers that handle things in different ways. And Gunicorn is the one that's used for Django. It's sort of the standard. So you're going to need to install that. SQLite is technically not supported by Heroku, and the reason for that is you have these local files, right? So db.sqlite, this file will grow and grow and grow and grow and grow as you get more data. And Heroku, like this is your production code. Heroku has data has places to store databases that are outside of your general code space, and it's optimized for things like Postgres or MySQL. But SQLite doesn't really fit into that. Like SQLite is a nice lightweight thing to put here for development or for smaller things, but Heroku doesn't like you to have it in your project. This is the same reason why you don't want to allow people to upload images to your Heroku instance. I think Heroku only allows you to have a maximum of 300 megabytes in your code, which that's like you're not going to get anywhere near that with just a Django project. But if you start adding images and video and audio and you have a huge database, you can quickly pass up your 300 megabytes. And then it's going to take a long time to push your code every time, and for various reasons you don't want to do that. So Heroku will want you to install a Postgres. Otherwise, what they threaten is that they say they'll wipe out your data every day if you're using SQLite. Now, in practice, I've actually uploaded some SQLite databases, and it seems to work fine, and they don't wipe it out as they threatened. But for this project, we want you to install Postgres. Postgres will, if you're using the ORM, it will work exactly the same as SQLite, and you shouldn't see any changes from that end. Yeah, I was thinking, is this GNU? But it's not GNUicorn, or this is a I don't know. Anyway, install this. That's fine. Install Python decouple. Okay, there's something that we're gonna need to talk about this and what it means to what your environment means on Heroku. White noise is dealing with static files, which is like your JS and CSS files. Which actually, yeah, I think you don't actually need any since you're not creating any views. All right, and if you're using virtual env, you need to create a requirements.txt. So you need to run this command pip freeze. Will create requirements. What this does is it tells Django which tells Heroku which version of everything you're using. So if we run this, we will get pip freeze. Whoops. All right, let me look here. Subble cd random cat requirements. Okay. Subble requirements. So if you look at what this will create, it'll make all of these packages. This is everything that your project is going to use, and it tells Heroku which version of them that you want to use. Some of these are not backwards compatible, so it's important that Heroku knows exactly what version of everything you're using. Let's take what can we? Let's okay. So when you made your Django project, you created this .env file, subble.env, which had your secret key and this debug thing. You want to make sure that it's in git ignore, so you're not committing your .env file because you don't want your secret key to be anywhere. So since you're not checking this in, how is Heroku going to know what your secret key is? Well, to do that, you will need to you can access it through Heroku. You can go into your settings, and add your config varies here. So here you'll see these are my secret keys. These are my pusher keys, which will come up soon. This is my debug. This is my database URL. So these are also not visible unless you have the Heroku credentials. So this is how you want to update your secret keys. You can also do it. You can also do Heroku config. Does this work? Okay, no, it won't work here. But you can also run Heroku, do it through the command line, but it's a little bit trickier. Settings, proc file. The last thing is proc file. We'll tell Heroku how to start your app. So it's basically, it's a one-liner. It's just saying, all right, when you kick off the app, use Gunicorn to run this file, and it'll start your Heroku app running, your Django project running. So this is you don't really need to know how this works. You can just copy this line into your proc file, and it should work. Heroku, you create an app. It will give you a funny URL like let me see. I think I have one up here somewhere. Like here, like Shrouded Gorge 49185. But you can rename that to something a little bit nicer once you get there. Yeah, secret key. Make sure you don't update your .env, and then you can just push to Heroku. If you want to run command line things, you do Heroku run, and then you can do like Python manage.py migrate, and things like that. And you can also look at your server logs with from Heroku using command line items. Are there any questions about Heroku before we take a break? If not, yeah, let's take a break, and I'll see you in 5 minutes. Oh yeah, Marshall. Let's take that offline. I feel like that's a more specific thing that I'd like to dive into, but that probably will not be interesting to students who either haven't gotten there yet or who haven't encountered that bug. But we should definitely, when we solve it, we should put the solution into the help channel, because chances are other students will probably run into that. Yeah, Michelle, we'll, so the second half I'm going to start talking about Project Week. All right, make your way back. And let's take a look at Project Week. Oh, this is Sprint Challenge. And this is this week's. Where's the Project Week? Oh, here we go. Project Week. All right, so for next week, after make sure you get all of your stuff done. Make sure you get your deploys and all of that out of the way. But once you're done with that, you can start taking a look at this project. Now, for this project week, you'll be implementing a MUD. A MUD, you may remember from the first week in Python, is a multi-user dungeon. But when you implemented it in Python the first week, it was a little bit of a misnomer. The MU stands for multi-user, but you may have realized that you can only have one person playing it at a time, right? There's no network connection or anything available. So it was actually just a D, I guess, just a dungeon. It was just lambda. But for this week, you will be actually implementing the multi-user part. Single user dungeon, good. That's a good name. LambdaMUD. Now we're going to go over what it takes to implement the multi-user part. I'll run a quick demo of what that looks like. Here's my MVP. This is really the minimal, so don't look at this as inspiration about what you should do, but this is really the minimum of what's required. So I have I think my server might have gone to sleep. So I'm running on the free Heroku. One thing about Heroku is that it goes to sleep when you haven't used it in a while, so it takes a while to wake up. All right, so I have two users running. One is named Brady, B-R-A-D-Y. One is named Brady, B-R-80. I'm outside the cave entrance. North of you, the cave mount beckons. This should all look very familiar. And I can type north, and I'm in the foyer. I can also see my other friend Brady is standing here. If I go south, you can see all of these commands. So one interesting thing that you may notice is that when someone else walks into the room, you can see them coming up in the other person's terminal, right? That's a very simple concept, but it's one that's kind of tricky when you have websites, right? Like so far we've learned how REST works and how APIs work. So basically, and this is HTTP. You make a request and you get a response. That's how most websites work. You make a request, you get a response. You make a request, you get a response. But how do you get a response when you haven't made a request? That's a little bit tricky, right? You can handle it through what's called polling. There was a good message in a Slack channel about how Twitter does it. Twitter does polling, which is every 10 seconds they say, "Hey, are there any updates to my Twitter feed?" No. Okay. Any updates to my Twitter feed? Oh yes, these need 2 new tweets, and it sends those updates every 10 seconds. That works for Twitter. Because 10 seconds happens, like it does. It's not so important that when someone tweets that you get it instantly, right? Like it's, even though Twitter happens pretty quickly, 10 seconds is they decided was an acceptable wait. When you're playing a game, though, it doesn't really work, right? Like if I'm standing in this room and I leave the room, you don't want to wait 10 seconds to find out that someone else has left the room, right? You need to get it instantly. This is, so you will be, for this project, implementing WebSockets. Now, what a WebSocket is, you can read up about that. WebSockets. What are WebSockets? WebSockets are basically using a web technology that uses TCP. So TCP is a bidirectional, full duplex way of communication, and that's you establish a WebSocket connection with the server, and then you can get messages going both ways. You'll be using a library called Pusher, which is basically a WebSocket. It creates an abstraction for WebSockets. It works for JavaScript. It works for React. It works for iOS. And it works for Android. It works for everything. And the code is pretty simple, and the documentation is pretty good. So we'll be using Pusher for WebSockets, and we'll talk a little bit more about that in a bit. But first, I'm going to keep going through this project. You'll be implementing a say command, which is like say hello. You'll notice I'm saying hello up here. I hit enter. Oh, I'm not in the right room. I need to go to the foyer. Say hello. So I say hello, and then this other user down here sees the message. Now, I know a lot of you are into games. Like, I'm very into games, but some of you aren't into games. And maybe you're thinking, like, why do I care about implementing a multiplayer game? Like, I don't want to make games for a living. I'm not trying to get into the games industry. Well, WebSockets have a lot of uses in non-game applications too. Things like Slack, like if you're building a chat app, and chat is similarly, you don't want to wait 10 seconds to get all updates, right? So you can think of, if you don't want to think about this like a game, you can think of it like a chat app. So we have different rooms, right? Like in Slack, we have different channels. You can think right now I'm in the foyer channel, and now I say hello, and everybody in the foyer channel will see the message. Now I change channels. So now I'm in the outside the cave entrance channel, and I say hello. And now people who are not in this channel will not receive this message, right? So there's a lot of different applications for WebSockets. Basically, anytime you need to push data, push an update to a user without them making a request, that's what Pusher is good for. For iOS users also, Pusher does push notifications. Now, push notifications is a different technology than WebSockets, but it's a similar thing, right? Where you can push a notification to a user who's not logged in, and you can let them know that something has happened. This is another app that I worked on the iOS. That's on iOS specifically. It's called Kaching. Ching. That was a live bingo game. Basically, if any of you have played HQ Trivia, that's a game where every day at like 7 p.m. they have a live trivia game, and then if you can play it and if you win, you get some cash. So I built a similar thing, except it was a bingo game, and we used Pusher for that, and it was built in React Native, and the app is on iOS. And so I know, even though I haven't implemented it in iOS, I know it does work on iOS. There's some trickiness that I'm interested to see how iOS students go through this, because you need to start a WebSocket connection. You need to initialize it, and if your phone goes to sleep, or if you click out of the app, it'll break the socket connection, and it needs to handle that gracefully. But that's something that I think that we'll figure out as we go along. Also, I think for iOS students, you don't want to have to type in N, right? You don't want it because then you have to click the thing and then put the thing and then push enter. So you don't want to. You will probably want to have different navigation than just text. So you can have like north, south, east, west buttons perhaps. This is the front end part of this project is up to you to run with. But I'm not going to get too much into that. Right now, I want to mostly talk about the server. So let's go back to this. Let's go back here. All right. So your assignment will be to implement this this MUD game, this multiplayer game, on the platform of your choice. We're providing a server, and I'll walk you through the code soon. And you'll be using the pusher service to handle the WebSocket connections. Blah 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 blah. This is you can look through this stuff on your own. The server is mostly completed except for the chat command. So the say command is you'll have to fill out yourself. All right, I'll talk about pusher a little bit more. All of this should look very familiar. We're basically giving you a server, and you're gonna have to take it, deploy it to Django, and then you're gonna have to create another project that accesses that server. And then you can test it. You can test your API using these commands. So all of this should look very very similar. All right, cool. Are you implementing a front end? David, you're iOS, right? So you will be implementing on iOS. So let's take a look at Pusher. Pusher.com. Hosted APIs to build real-time apps. Products, we're just using basic Pusher, but let me see. Where's the iOS? So on Swift, Pusher code just looks like this is basically what the Pusher code looks like. Pretty simple. With JavaScript, it looks the same. Android, Objective-C. It handles all of these backends: PHP, Node, Ruby, Python. By Python, they mean Django usually. Go. So Pusher supports a variety of servers and clients. And also, David, I didn't. Maybe you missed this, but Pusher also handles push notifications. So if you want to learn how to implement push notifications for your iOS apps, Pusher is a good library for that. Again, I worked on a project making a bingo game, a live bingo game that used push notifications to use Pusher to send push notifications to say like, hey, the game is starting in 5 minutes. Get ready and jump on and play with us. So this is a really cool library, and there's a lot of powerful things you can do with it. And it has applications for gaming, for if you want to do a chat app or anything, anything where you want to be able to push data to your users outside of the API request response framework. All right. So let's see. We're handing you a API server, mostly built out. You should be able to pip m3. I'll just run this server and get started. So here we already implemented things like user accounts. We're giving you the room class. We're giving you the player class. If you look at the room class, this should also look very similar to your week one code. We have a title, we have a description, we have N2, S2, E2, and W2. We have this method connect rooms, and then we have this other method that will get the player names. But so this is new, but we'll take a look at that later. This is very intentional. This should also look familiar for the code that you wrote in week 3, which was your graphs. So in that week, we wrote code to randomly generate a large set of rooms, and you can use that code and you can copy it and directly apply it to your to this LambdaMUD project. So if that's so even though the project is mostly focused on front end, you can also use your code from week 3 to write to create more rooms than just the basic 4 rooms. And it should all work. It should all work exactly the same. Players should also look similar. We have the current room. We have the player ID. This is new, but now you understand what the UUID is. So we're creating UUIDs to identify each player. All right, so let's. Do I have this set up? I want to demo some pusher stuff. Actually, I think I can demo it using our my MVP app. So when you log into Pusher, you will see. Let's look at our move function. Okay, so move. We have this stuff is all pretty basic. So we have direction north, direction south, direction east, direction west, and then we set our next room to this. And then if our next room is valid, then we set the player's current room to the next room, and then we save. All right, and now we have this code that says pusher.trigger. All right, this is the line of code that sends out pusher notifications. All right, we can see that working with through this. Pusher comes with some nice dashboards. When you log in, you'll create a pusher instance and see you can see how many people are logged in, how many people have active pusher WebSocket connections, and then you can also see the messages that are passing through. So let's look at the debug console. The debug console will let us know. So we have Brady's to the south. So when I move south, I pushed there. Let me do that again. So I'm moving north, and this is pushing a notification to this user that this other user has walked north. All right, and let's see what showed up in our pusher logs. So if I walk south, we get another message. We can take a look at this message and see it pushed this code. So this is the payload. BR80 has entered from the north. You can see that code showed up here. The way we got in here is through JavaScript. So I took the payload and then I put it into p tags and I appended it to this div. But we also have this. We have these other things. So we have channel name and events name. All right. How does the channel name? What does channel and event mean? So when you log into Pusher, first thing you'll need to do is initialize. So you create a Pusher app. Pusher app has your app ID, Pusher key, Pusher secrets, and Pusher cluster. These are all environment functions, environment variables, which is why they're hidden in our secret.env file using config. You're going to need to create your own Pusher accounts. It's free, up to I think 200,000 messages per day. So you definitely should not hit your limits. But this will tell you which Pusher instance you're using. And then you need to initialize the connection, which, where does that come? Okay, I guess this Pusher, I think that's going to be on the front end. That's actually on the front end where you initialize that. We have that in our docs. Where did the Pusher docs go? Oh, it's in this page. Oh, products, channels, pusher.trigger. Okay, anyway, there's a line of code that will let you subscribe on the front end. Oh, here we go. Pusher.subscribe. So this is your front end. This is the front end code. The first thing you need to do is subscribe to a channel. And then you bind in events to when you receive a notification on that channel. Then you do this thing. All right, so it's pretty simple. You subscribe to a channel, and when you receive an event on that channel, you do something. Whether that's take your payload and append it to a div, whatever I'm not sure how it works in iOS, but it'll probably be something similar where you take the data and then you display it somehow. So a few important concepts to understand with Pusher are channels and events. So channels are it's like a broad, just a broad channel. Right now, if you go into the server code, all of our channels are called broadcast. That's a little bit of a misnomer since you're not necessarily broadcasting to everyone, but it's just called broadcast since it's sending to a large group of people. So you on the front end, you're going to subscribe to this broadcast channel, and that means every time you get a broadcast event, you're going to process it. Second part of this is this trigger. Oh, wait, sorry, I have this backwards. You're going to subscribe to your player channel, and you're going to look at broadcast events. Sorry, if that was confusing, let me back up. You're going to subscribe to an individual channel, and you're going to look for broadcast events. All right. So every player will have their own channel. That's what this is saying. P-channel PUUID. Remember, UUIDs are unique identifiers. So you're going to if I'm a user, I'm going to have my own unique identifier, and I'm going to subscribe to that channel. So that means every time a notification gets pushed to a channel, I will get it. Now you're going to get you're going to have events. So broadcast is an event. So whenever I get something to my channel, I'm going to check if it's a broadcast event. I'm going to do something with it, and the something with it is will be up to you to figure out. Here we're just putting up an alert that's saying we received an event. For iOS, you just print. I guess this is just going to print to your console, and so on. But yeah, so here when I move, I'm going to check all of the players that are in my current room, and then I'm going to send this notification. You'll see for each player, that's the current players in the room. Then we'll send this message out to each of them. And then here's the message, player.username has walked, and then we get our direction. So we'll say like Brady has walked north. And then for all of the users in the next room, you will get a message that says Brady has entered from the south. Oh, is everyone following along? Let's take a step back and see, are there any questions about Pusher so far, about WebSockets, about what we're doing here? Are there any questions, or are people getting it, or are people just totally lost and you don't even know how to ask a question because your brain is exploded and is in pieces on the floor? Some of these details, it's okay if you're a little bit lost, because I think that once you get in and you start working with it, it'll make a lot of sense. Like the code is actually not that complicated. Like if you look here, this is your server code, 3 lines of server code, and this is your client code, 4 lines of client code. So it's not too complicated. And once you see it actually working, you'll find it's not too hard to pick up. Yeah. I can totally appreciate that sentiment. So what I'll say about this, and is that when you get into the real world, when you get into your actual job, it's gonna be a lot like this. All right, you're gonna say, hey, we're kicking off this new project. You're gonna get, here's a ton of stuff that you have to read. We're gonna talk through it super quick, and there's gonna be a lot of stuff that you have no idea about. And then they're gonna say, all right, so any questions? And you're probably gonna feel a lot like you feel right now, and say like, I don't know. I don't know what's going on. Um, but you're still like, you should still, you want to get as much of that out of the way as possible, right? You want to make sure you have a good understanding. So even though it's really hard, that's one of the skills we want that you should be practicing. So so think about it. Try to like examine your mental model and say, all right, what's missing? Um, Also know yourself. You know, a perfectly valid answer is like, I'm confused, but I think I'll get it once I dive in. I think that's usually how it works. Um, but then think about, all right, what do I want to know now that will help me out. Like let's say if you have some time over this weekend and you want to get a jump start on it. Like, all right, what do I need to know so I can work on this weekend? Maybe you don't need to know exactly how Pusher works, but maybe you have some questions that are like, hold on, like what is a WebSocket, or like what does it mean? What are some of the fundamental misunderstandings that you have? And if that's something that you can ask, then this is a good time to ask it. If so in the past when I ask questions and students are like, I just don't know, like I'm so confused, I don't even know how to ask a question. What I say is that, you know, in the real world, your boss is not testing you, right? Like they're not giving you an assignment to test if you can do something. They're going to give you an assignment because they want you to build it. They need you to build it, and they don't want you to be stuck. Like if you're stuck for 2 hours confused and making no progress, that's 2 hours of wasted money, right? Like they're not getting anything out of it. So if you're blocked, if you're confused, they want you to get unblocked. If there's an answer, if you have a question, they will tell you the answer. That's sort of been my approach. Like I try to not be so tricky. Like if students ask me a question, if it's a good question that I can answer directly, I'll answer it. You know, like if it's even if it's supposedly like a test on your sprint challenge, like I try my best to answer things straightforwardly, because that's what will happen in the real world. Your boss wants you to get things done, and they want you to do it well. And they're not trying to trick you. But that said, they also are very busy, right? Like they can't sit with you and walk you through it one at a time. So if you're blocked, if your brain is blocked, what you want to do is think of a good question that will get you unblocked. And that's a good skill to learn. And it's hard, but how can you look at what you don't understand and what you don't know and what you're having trouble with? Come up with a good question that will take you from blocked to unblocked. That your boss or your manager or your senior engineer can answer quickly. And you know, we're here in computer science, we're throwing really difficult concepts at you to really stretch your comfort zone. We want to push you out of your comfort zone, and we want you to use all of your mental faculties and critical thinking skills and everything to ask questions to get yourself to make sure that you understand what's going on. For the record, because every app has a provisioning profile and a deep security model, you cannot run 2 instances at the same time. Every connection to the network is HTTPS by design, and this sounds like we in iOS may need to validate this via print statements. Oh, are you saying that you cannot run, like how I have 2 windows open here, that you cannot run two instances at the same time? You can't. That's an interesting point that I didn't think about. Well, I think if you have, say, an iPhone and an iPad, you can run it on both, and you should be able to look at both. Or if you have it on your phone and then someone else has it on their phone, you should be able to do this. How do you usually test? Do you guys use TestFlight? Okay, well, it should work on TestFlight if you can get things out to TestFlight. Um, also, um, also, let me think. Let me think. I wonder if we have your server address, if you can access the server via your phone, and then someone with a web interface can access your same server using like a web page. You use the simulator. Um, yeah, we'll talk. We'll maybe when it comes down to the practical stuff, we'll figure this out, and then maybe we can also pull in some your iOS instructors and see if they have any advice for how to do this. But I feel like we'll figure it out. We'll figure out a way to test it. TestFlight is basically like a beta testing app for Apple. You it doesn't it's a way to basically beta test your app. You can send invites to users, and they don't need to the bar for passing for getting Apple's sign off is much lower than for a regular app. But anyway, if you're confused, think about some good questions to get yourself unblocked. Also, I really recommend taking a look at this over the weekends. Again, definitely finish all of this week's material first. Get your Heroku deployed. Make sure you have all of the deliverables out. And then once that's done, start taking a look at the server and start running this. Start playing with it. Take a look at Pusher. Make your Pusher accounts. Look in the debug console. See if you can understand what's going on here. Like here, you can see that our channel. We're subscribed to these different channels. We're subscribed to, this is our UUID. This is our 32 character ID. Our event is broadcast. And these are the messages going by. So try playing with it. See if you can get your messages to show up. Look through the server code. We intentionally, it's kind of complicated, but the fact that we've been going back over this over the past couple of weeks, you should start to see the parallels in that we created classes on Python, and classes in Python are pretty close to your model, to the model layer. Your controller will be, let's see, that should be in views, API, URLs. So this is sort of your controller layer. This is where this is how we route our commands. We have the move commands, say command you're going to need to implement. This initialize command will set up your stuff. And then you should be able to hit these. You should be able to test these API commands using where's our README? We have these API commands that you should be able to test. Login and registration are already implemented for you. So once you get the server running, you should be able to do this straight away. Can I suggest a workflow for next week's project? Yes. Get your server up and running. So first thing to do, clone this repo. Get the server running. Let's see, where am I here? I did pip m3, pip env3, pip env install. And I'm surprised that you haven't heard of it before as an iOS student. But I guess if you're using the simulator, that should work. But isn't the simulator on the computer? Or you just okay? So I guess if you're not beta testing, you don't really need to. But you can deploy from Xcode to your device, right, and play with it on your device. So we'll figure it out. I'll definitely so next week Beej is officially leading the is officially your instructor for LambdaMUD, but I'll be around, and I'm really curious to get into some of these details. Every cohort we do, there's always some new stuff that come around, but that's what makes it fun, right? It keeps us on our toes. This is also, so the server should not, as they're saying, get the server up and running. Test out your API commands. Make sure that you can create users using these registration API commands. You can use curl or postman or whatever you like to use for your to do API requests. You should be able to get these keys. This should look very familiar from your Django week. Do you learn to run React with Django, like in the same folder? So you will not be doing that, Brian. That's a really good question. So you could create a project. You could create a project where React is in the same project as your Django server. But for this project, we want you to deploy it in a separate app. So your Django app will only be the API server, and then you're going to create an entirely new Heroku instance, or excuse me, however you want to deploy. You're going to have an entirely new project that will access your API. You may run into some CORS issues since you're accessing an API from a different server, but if you set up your CORS right, you should be able to access it. How long does a WebSocket connection persist? Will it disconnect as soon as the browser window is closed? Yes, I believe it will. I believe it will. Yeah, Brian. So you don't have to do React in Django. So you don't have to. You don't have to write any. You don't have to do Django templates. You can do it. You can deploy Netlify if you want. We have some students who like Netlify for. Netlify is really good for hosting single page. What are they called? Basically applications with no database. And since your application will have no database, it's only hitting an API. Netlify is a good choice for your React. And you can write it however you want. You're gonna use Axios. You're gonna use Axios to make these API requests. Guess we don't have Axios here. Yeah, Adrian. So WebSockets persist. Basically, as long as if we look at our code and we look at our console, tools, developer, web console, we will see up at the beginning we have state initialized. So as soon as you load your pusher instance, you'll see it initializes the connection, and as soon as you close it, the connection will disconnect. Now again, I think this is trickier for iOS because iOS has a lot of things that can, like if you close the app, I think that will disconnect the connection. And when you reopen it, you'll need to do some handler, like when the app reopens, that you'll need to reestablish the connection. So there may be some unique challenges there, but as for web, all of this is done in JavaScript. So as soon as your JavaScript loads, it'll create your pusher instance. You'll subscribe to a channel once you're initialized. You'll need to, in order to subscribe to a channel, you'll need to have your UUID, which means you'll need to log in and get a response. So you'll see in the API command for login, you register. You can create your user account, test name, password, and then you'll get a key. And then you make a call to initialize, and then you send in your token here, and then you will receive everything you need to initialize. So you'll get this UUID, which you will use to subscribe to your pusher channel. You'll get your name, which you can display somewhere. And then you'll get your starting room. So for this player, you get initialized and you're starting outside of the cave entrance. And this is the description, so you can print that out right when that user logs in. Okay, so let's see, Michelle, I got sidetracked. So first step, download the repo. Second step, make sure your pipenv and everything is set up. Make sure you can run your server, and then try to do these initial commands. So make sure you can register. Make sure you get a key back. Make sure you can initialize, and then you get this response back. And you should be able to move around using these commands. So this is all before, this should all work out of the box. You should be able to, let's see, did I pipenv shell? So I think this should work. So I just I just started this. This is a fresh install. So I should be able to do, say, manage.py. What am I doing? Make migrations. Okay, I need to create my d.env, the subble.env. I'm just going to copy it from another thing. So cp local. Not here. Okay, maybe not. Django adventure.env. Nothing there. ADV project. There we go. Finally, .env. Now I have a .env file here. Now I can run my server. Now I'll migrate my data. Manage, migrate. Okay, here's something I forgot to mention. So we created our models. We have our server code running, so that's the controller. There's one part that's missing. That's the part where we create the world. So I created this file, createworlds.py. This should all look very, very familiar. So first we're importing our models. Then we have this Python code. We delete all of the rooms. That will just let us start fresh. And then we're creating these rooms. So room, title, description, room, title, description. We need to save all of these new records, and then we connect them. So we do connect rooms north-south, connect rooms north-south, connect rooms east-west. This is your third time around, so this should all look pretty familiar. You're still gonna have to do this. This sets up your model. So to do this, we run the shell. So manage shell, and we get our Python console. So you copy all of this, you paste it, and now your room is set. Now your world is set up. So now we created all of these rooms. We established the connections between them, and then this last line, just when you create your rooms, it will put all of the players starting outside. Now we can exit this. Now we can start running these things. So let's create a user. We'll register our user first. Failed. Oh, I need to run server. Manage, run server. Now we can create a new window, and we can access our server. All right, so it works. You can see we made this registration API call. Let me move this to a different window so we can see the server messages come by. So we registered. Look, when I try to register again, I'm gonna get an error because a user with that username already exists because I already registered with that name. So now I have a user named test user. I should be able to run this this API, this login command. Login. So I'm logging in with test user and test password. You see another request came here, and I get the key. I get the same key that I got up somewhere. Where did it go? Okay, well I got that same key. If I give it the wrong password, it will give me an error message. All we're running as expected. So now I have this key, right? I have this key, and now I can run this init command. Init. So I'll take this, but I need to use my new key. So I'm going to put this here. and I should be able to run this init here. And now I get this response. I get my UUID, I get my name, and I get the room that I'm in. And then I also get the names of the players in my room, which there are currently none. All right. I can also let's create another user. So I'm going to register a new user. Let's name him new user. New user. We run this curl command. Clear. We get our key. We get our key. Now we can initialize with our new key. Here. And we're going to get our response. So we get our UUID, our name, our title, the description. And then you also see the players in our current room, test user. So test user is our first user, right? So now I'm standing in this room with test user. If we run init again with our first key, we should see new user standing in our room. New user. All right, so new user is in our room. Now we can also move. We can also move by API command. So let's have one of our users move north. So we copy our key here. So remember, the key is the identifier and whatnot. Marshall, that's awesome. So let's move. So now I'm north, and now we moved north, and now I'm in the foyer. Description here, and there's no players in our north room. Now, I haven't written any code. I haven't written a single line of code, I guess, besides copying over the .env file. So I created this, but other than that, I haven't written any code. So all of this stuff should work right out of the box. So this is the first step. Make sure you can do all of this. We also have pusher set up. So if we look at our pusher logs are here. I think I'm in the same pusher instance. So let's try. So we walked north with this guy. Let's what's our other user ID? Let's log in with what's test user. Should have kept this key around so I don't have to reinitialize. Not register, login. Where is the login? Login's here. Okay, so I have new user's key is here. Wait, that's the one we were just looking at, isn't it? Okay, I want test users. I want new users ID. Okay, here we go. This is the other key. Okay, so now we're gonna move north with new users, and we should see a pusher thing come up here. So let's move north. So we move north. We see test user here, and no pusher event has come through. All right, let me see. Why is that? Maybe I'm looking at the wrong pusher instance. Let me go back. Dashboard. 3 things. Am I looking at the right one? Okay, post API move. Let's move south here. Move south, and then okay, the message didn't come through. Not sure why that didn't come through. I will API.py. So we're moving we should have triggered something here and broadcast it here. Let me see. Can we print? Print. Do we get here? I want to see if this shows up in our logs. And our server is running here. So south, we moved south. And now we want to move north. Oh, you cannot move that way. North. Do we get here? So we do get here. We get this code in our server logs. And we're not showing pusher events. I'm not sure where that's coming from. Maybe it might be that my my pusher was not instantiated right since I copied over my .env. Anyway, you should be able to run all of this. All of the code is actually functioning okay. I'll look into this and see why it wasn't showing up. So we're running out of time. But once you get that, you want to implement the say command. So say this is like if you do say hello, it should show up. That is currently not working. It's not implemented yet. But this should be pretty few lines of code. Like I think my solution for this was about 10 lines of code. So that's you don't even need to do this yet. Maybe you can start getting your front end working before you do say. But once you get your server running, and once you're able to test your API, then you can start working on your front end. And for the front end, you'll need to implement login. So my app went to sleep. So you'll need to do username, password. Oh, you also need to do registration. So if you already have an account, log in. Otherwise, you need to register an account. Some user, I think some user, new password creates. I think it doesn't like it. It's too common. I'll do quirts ASDF. My error messages are broken here. Okay, so I created a new user here, and then it's storing the key. You can't see it, but I'm storing the key in local storage, my API key, and then I'm using that for all of my commands. So now I should be able to north, south, and you'll see the new user come up here. So once you do this, you can start to implement the say command. Say hello. Make sure it all works with pusher. And then from there, okay, once you get all of this working, this should not take too long. Maybe one day, maybe, to get the front end working, that will take some time. But the server stuff shouldn't take too long. But once you get all that, then this is MVP. Once you get to MVP state, you should take this and run. Like make the front end look beautiful. You can add more backend commands if you want. You can add more front end things. It doesn't have to be a text interface like this. In the past, some students have done like text navigation. Some students have linked images. So each of these rooms come associated with images that load in. iOS students will probably want to figure out a different interface for moving around than typing. So you can make buttons for people to move. The sky is the limit. The sky is the limit. So we hope that you take this and run with it. You can run your code from week 3 from graphs to make a huge maze that your players can navigate through. You can really take this and run with it. Deploy the backend on Heroku before creating the front end. Yeah, you'll probably want to do that. You can develop locally. I think you can develop locally by using localhost and just having different local servers. But I think deployment, especially while it's fresh in your brain, deployments. I like to get that out of the way sooner than later, and then you can start. Because one problem is you cannot look at local hosts. You can't hit a local API from a deployed app. So if you deploy your app to Netlify, then you're not going to be able to look at your server if it's only running locally. So yeah, I think Heroku is a good thing to get out of the way, especially if while you've just done it and while all of the little details are in the front of your brain. All right. Any other questions? Again, you're gonna get. We're skipping ahead a little bit. So starting on Monday, Beej will be joining. Well, Beej will officially be leading it, but he will be leading another kickoff where we'll go over all of this stuff again. But first get all of your stuff from this week done. Get your Heroku deployed for your Notes app. Finish the MVP. If you're almost there, get all of that stuff wrapped up. Check with your PM and make sure you're all good. Try some stretches. I do recommend trying some stretches if you haven't gotten to them already. And then try getting this stuff running over the weekend. Like download the clone the app. I don't know do we say clone or fork? I think we say fork, right? Anyway, get the code, get it running. Try these API commands. Download Pusher. Play around with Pusher. Read the docs. So Pusher has really good docs. I'll post some to Slack after lecture. But Pusher has really great documentation, which is one of my favorite things about it. So look through the Pusher documentations. Maybe read up on WebSockets. Try to, if you have time, maybe get your say command running. And most importantly, think of some questions. So dive in, get your hands dirty. Figure out what's confusing you, and think of some questions. And Beej and I will be there on Monday to help you out and help get you unblocked. All right. Well, with that, also I should mention that tomorrow. So tomorrow is officially the sprint challenge, and at noon, I will do a solution lecture where I'll deploy an app to Heroku. But I also want to spend some time talking about wrapping up some of the loose ends from last week, since the Graphs week was cut short by the staff retreat. I didn't get to talk about all of the stuff that I wanted to, but there is a connection between the stuff we did in Graphs week and this week and your project week. So I want to help connect the dots, and I know that week kind of destroyed a lot of people. So I want to help pick up the pieces and put it together, because this is a really important and really practical and really useful skill. So don't miss out on sprint lecture tomorrow, even if you breeze through the Heroku deploy, because we will have some cool stuff to talk about. And if you have some questions for me on LambdaMUD tomorrow, I'll also take some time to answer that as well. So I guess that's it. That's Django, and I'll see you all tomorrow at noon. All right, thanks everyone.